Hello and welcome back to our channel. Today we'll be working on part B of the problem called Marble in Bowl. Let's get started. Question 8, part B. If the bowl is infinitely thin and is placed on a surface at 45 degrees to the horizontal, such that the rim is horizontal, and U is set to twice the minimum calculated in part A, what will the displacement of the marble be when the marble hits the slope? Assume the marble is infinitely small, that the marble is initially moving to the right, that the marble moves in the same plane as a line of greatest slope of the inclined plane, and that the plane slopes with the right side higher. Give your answer in column vector form with right and up as the positive x and y directions respectively, with all values to three significant figures all in terms of a. Do not include a number for the z direction. Please pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. We'll start by drawing a diagram, as shown here, and labeling some points. Now, let us first place A at the origin and enlarge the setup by 1 over A about A. This will simplify calculations, although we will need to reverse the enlargement at the end. Now, let X be the point of contact between the bowl and the plane, and C be the point where the marble hits the plane. Since our old u squared was 17 over 3 of g, our new u squared is 68 over 3 of g. From part A, we have u squared equals 8 over 3 of g plus v squared, and therefore v squared equals 20g. V is therefore equal to the square root of 20g. Please note that sine theta equals root 8 over 3, which is equivalent to the square root of 8 over 9, and that cosine theta equals 1/3. We will need these values later. We now have a pair of parametric equations for x and y in terms of t. The first one is x equals negative 1/3 of vt plus the square root of 8 over 9. This gives us t equals negative 3 of x minus root 8 over 9 all over v. We also have y equals the square root of 8 over 9 multiplied by vt minus half gt squared, all plus 4/3. These equations can be obtained by using the constant acceleration formulae covered in single maths. Now, substituting this value of t into y, we have y equals negative 3 of x minus the square root of 8 over 3, all multiplied by the square root of 8 over 9, minus half g multiplied by negative 3 multiplied by x minus the square root of 8 over 9, all squared, over 20g. Expanding the first layer of brackets gives us y equals negative 3x plus root 8, all multiplied by the square root of 8 over 9, minus 9 of x squared plus 8 over 9 minus 2x multiplied by the square root of 8 over 9, all over 40. Expanding the next level of brackets gives us y equals 8 over 3 minus root 8x minus 9x squared plus 8 minus the square root of 288 of x all over 40. This further simplifies to give negative 9 over 40 of x squared plus open bracket root 288 over 40 minus root 8 close bracket x plus open bracket 4 minus 8 over 40 close bracket is equal to y. Therefore, y is equal to negative 9 over 40 x squared minus 17 root 8 over 20 x plus 19 over 5. Going back to the start of this part, we have that the coordinates of x are root 2 over 2 and 1 minus root 2 over 2. So the equation of the plane's two-dimensional projection is y equals x minus root 2 plus 1. We now have negative 9 over 40 of x squared minus 17 root 8 over 20 of x plus 19 over 5 equals x minus root 2 plus 1. Collecting like terms and then multiplying every term by 40, we have negative 9x squared minus 40 plus 34 root 8 all in brackets multiplied by x plus open bracket 112 plus 40 root 2 close bracket equals 0. Placing these numbers in a calculator and solving gives us x equals negative 16.3 to 3 significant figures, and therefore y equals negative 16.7, also to 3 significant figures. Therefore, the final column vector is negative 16.3, negative 16.7. However, we also need to reverse the 1 over a enlargement, and therefore the final vector is actually s for displacement equals negative 16.3a, negative 16.7a, and that's our answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.